The radioactive isotope plutonium-239 has a half-life of 25,000 years. How long will it take for 100 grams to decay to 20 grams? Round your final answer to the nearest year. So the first thing we need to do is this statement. Half-life of 25,000 years. That will allow us to find the rate of decay of plutonium-239. So let's assume for a minute that we had, first off, our formula. Oh, there's lots of versions. The basic formula is the same as the continuously compounded interest rate. But you could also use, like for this one, Q equals Q sub 0 e to the kt. I have seen A for amount equals initial amount e to the kt. I've seen lots of different versions, Q for quantity, but it's all the same formula. I don't really care which one you use, as long as you know what everything stands for. So if we were to start off with 100 grams, not because it said 100 grams here, you can start off anything you want, as long as, let's see, and then time, if we run for 25,000 years, so that's T, then I'll put the R to the right, then it'll go through a half-life. This 100 would end up being 50. So you could have also used 50 here and 25, or you could have used 20 and 10, or you could be more general and write P and 1/2 P. Regardless of the numbers you use in doing the half-life, as long as the relative relationship, the after value is half of the initial value, as long as that relationship holds, this will all reduce, dividing by 100, to 1/2 equals e to the half-life times r. We can now proceed to solve for r. Taking natural log of both sides, we have natural log of 1/2 equals 25,000 r. And then if I divide by r, I get r equals natural log of 1/2 divided by 25,000. Some people actually memorize this formula. Unless you're into math biology and doing half-life or paleontology or that type of field, I don't know if this is worth it, because I just solve it. It gives me practice of all these skills anyway. But some people memorize this. If you know how to use it and you memorize the formula, wow, you studied in a different way than I did as a student. But you can still get full credit. This is the rate. And I am not going to approximate this because this has a nasty decimal approximation. That's the rate. I have R. That's important to find. Now we can go to the other question. If we start off with 100, using the R that we have, and the T, I don't know what T is. How long until it's 20? We can go back through the basic same steps, knowing what R is, and solve for T. First, dividing by 100, we would get 0.2 equals e to the RT. Keep in mind, I'm writing R even though I know the value. I just don't want to write this ugly number or its decimal approximation. Natural log, RT. And solve for T, we would get natural log of 0.2 divided by R. And now we go to our calculator. So we have natural log of 0.2 divided by parenthesis R. What's R? It is natural log of 1/2 divided by 25,000. I think I have one extra parenthesis. Oops. Let me double check. Numerator. Denominator should have a parenthesis around it. Yep, I just had one extra parenthesis. There we go. 58,048, nearest year, 58048. this is approximately how long it would take that isotope to decay from 100 grams down to 20 grams. This is probably a good time to note that if you did work out R, and I did 1/2 of my head to get 0.5, it's a weird looking number. This is scientific notation. So this is times 10 to the negative 5. So I'd have to move the decimal place 5 to the left. 1 would get in front of the 2, 2, 3, 4, 5, 4 zeros, then 2, 2, or 277. Like R equals negative 0.1234277. That would be an approximation of R. So what if we used like that much of it? It's not all of it. There's more information. What if we did natural log of 0.2 divided by R as natural log of 0.2 divided by negative 0.1234277? We're off by over 50 years. It is so important to not use rounded values in calculations. Maybe it's not important to be off by 50 years, but that might put this piece of whatever it is into a whole different epoch of history. And maybe you rewrite history because you were off by 500 years or 50 years or 2,000 years or whatever. That all happens from rounding. R doesn't equal this value. R equals this value. Now, if you're careful and you store this value, currently it's stored in the temporary answer button, and you use the entire value, then you're not using a rounded answer, and you get the correct answer. So you just need to be very careful. Even if it says round somewhere, don't round until your very last opportunity. Don't use a rounded answer anywhere before then, or else you will get wrong answers. That error of rounding will compound and get worse and worse and worse. All right, hope this helps.